The objective of human resource strategy is to manage labor and design jobs so people are effectively and efficiently utilized. Job design is the act of specifying the contents and methods of jobs. It answers what will be done, how will it be done, who will do it, and where will it be done. Ergonomics is the incorporation of human factors in the design of the workplace. It is the study of the interface between man and machine. It is also called the human factors. Job design continuum is consists of job specialization, job enlargement, job enrichment, employee empowerment, and self-directed teams. Job specialization, the division of labor into unique tasks, work that concentrates on some aspects of a product or service, breaking jobs into small parts and assigning specialists to them. Job enlargement, giving a worker a larger portion of the total task by horizontal loading. Job enrichment, increasing responsibility for planning and coordination tasks by vertical loading. And self-directed teams, group empowered to make certain changes in their work processes, may be organized for long-term or short-term objectives. It is effective because it provides employee empowerment, ensure core job characteristics, meet individual psychological needs, greater work satisfaction, and higher quality. Job expansion is adding more variety to jobs, intended to reduce boredom associated with labor specialization. Job rotation, workers periodically exchange jobs. Motivation and incentive systems. According to Taylor's scientific management, workers are motivated mainly by money. Similarly, based on Maslow's theory, people are motivated by hierarchy of needs including money. Examples of motivation and incentive systems include bonuses, cash or stock options, profit sharing, profits for distribution to employees, gain sharing, rewards for improvements, incentive plans, typically based on production rates, knowledge-based system, rewards for knowledge or skills. Method analysis, analyzing how job is done, focuses on how task is performed, used to analyze movement of individuals or materials using flow diagrams and process charts. Activities of human and machine and crew activity using activity charts. Body movement using micromotion charts. Flow process charts focuses on movements of the operator or flow of materials. Worker machine chart focuses on idle and busy time for machines and operators. Motion study, the systematic study of human motions while performing an operation. Micromotion study, use of motion pictures and slow motion to study motions that otherwise would be too rapid to analyze.
Work measurements is how long it should take to do a job. There are four types: time studies, predetermined time standards, standard elemental times, and work sampling. Predetermined time standards are determined from times in published tables and data. The most common method is method time measurement, or MTM. Standard elemental times, on the other hand, are derived from the firm's historical data. Time studies uses observation to get the average time and pace to set the standard. Work sampling is a technique for estimating the proportion of time that a worker or machine spends on various activities. To determine the number of cycles to be timed for time studies, the formula would be n is equal to z times s over a times x bar squared. Z is the number of normal standard deviations for desired confidence. S is sample standard deviation. A is desired accuracy percentage, and x bar is the sample mean. The desired confidence level percentage, which is 90, 95, 95.5, 98, and 99. An example would be a study yield a mean of 6.4 minutes with standard deviation of 2.1 minutes. For desired confidence level of 95%, how many cycles must be observed if the desired accuracy is within 10% of the mean? Using the formula, it would look like 1.96 times 2.1 over 0.10 times 6.4 and square them all, and it will give you 41.36 or 42 cycles. If the standard deviation is not given, the formula is square root of summation of x sub I minus the mean squared over n minus 1. Standard elemental times has formulas like observed time, which is the summation of all recorded time over the total number of recorded times. There's normal time, which is observed time times PR job, which is performance rating for the entire job, and standard time, which is normal time multiplied by AF job, which is allowance factor. Allowance factor for the job is computed by 1 plus the allowance percentage based on job time. Another standard time formula is normal time times AF day. AF day is the allowance factor, which is computed by 1 over 1 minus A day. A day is the allowance percentage based on work day. A chart is given with a performance rating of 1.13 using an allowance of 20% of job time. The chart has 9 observations, which are 1.12, 1.15, 1.16, 1.12, 1.15, 1.18, 1.14, 1.14, and 1.19, all totaling up to 10.35 minutes. To compute for the observed time, it's gonna be 10.35 over 9, which is gonna be 1.15 minutes. To compute for the normal time, it's 1.15 times 1.13, which is 1.30 minutes. To compute for the standard time, it's 1.30 times 1 plus 0.20, which will give us 1.56 minutes. That would be our standard time. The formula for work sampling is n equals z over c squared multiplied to p multiplied to 1 minus p, or z squared multiplied to p multiplied to 1 minus p over c squared. In order to get c, it's gonna be z multiplied to the square root of p multiplied to 1 minus p over n. To get p, it's observed count over n. A problem for work sampling would be the manager of a small supermarket chain wants to estimate the proportion of time that stock clerks spend making price changes on previously marked merchandise. The manager wants a 98% confidence level such that the resulting error will be within 5% of the true value. What is the sample size? The proportion estimate would be given, which is 0.5. Using the formula, we would have 2.33 over 0.05 squared multiplied to 0.5 multiplied to 1 minus 0.5. That would give us 542.89 or 543.